Good day, learners. I am Mr. Diteko from Motewa District, Subject Advisor for Natural Sciences and Technology, Grade 4, 5, and 6, Natural Sciences in Grade 7. Today's topic is energy transfer to the surroundings. Energy transfer to the surroundings. I want you to have this question in your mind and keep it as we move on. If energy is not used, if energy is not used, can we lose it? Or it can be transferred to the environment or the surroundings. Secondly, keep it in mind that no one can sit down and say, now I'm making my own energy. Or no one can sit down and say, now I'm destroying this energy. If it's not properly used, where does it go? Remember, it can be stored in fuels. It can be stored in the food that we are eating. Also, coal can store energy. Now, allow me to ask you the following things. Number one, can the car lose energy to the environment? The second one, can light lose energy to the environment or release energy to the environment? The heater that we are using at home every day, more especially during winter time, can we lose energy to the environment? The generator that we are using, can that generator lose its energy? Keep it in mind that that energy is very much important. Look closely at the picture. Through the activity that we are doing at home every day, such as washing our clothes, cooking, and the others, through those activities, can we lose energy to the environment? Let me make an example. Can it go through our doors, our windows, our roofs? The solar panels at the roofs of the house. The solar panels, the ones that are storing energy from the sun. If that energy is stored from the sun by the solar panels, it goes inside our houses. When we use it, can we use that total amount of energy, 100%? Or there is a certain energy that you're going to lose through lights, heaters, generators, and the other appliances such as irons that we are using every day at home. Energy transfer to the surroundings is the process by which energy is relocated from one system to another. The energy that is moving or transferred from one system to the other system. For example, through the transfer of heat, work, or mass transfer. It can be transferred bit by bit or through mass transfer. But the most important thing is that energy can be transferred from one system to the other system. The energy is transferred to the surroundings as a thermal energy and light. We'll see as we move on. It can be lost as thermal energy. Also, it can be lost as light. Most of the energy is transferred as thermal energy, which is not useful, and only some of the energy is transferred as light. Right? Very much important. Once that energy is not used, is going to be transferred to the environment. Or let me put it this way. Once that energy is not used properly, so is going to be released to the environment. And we've got different ways in which energy is released to the environment. And always, whenever energy is released to the environment, that environment where energy is released to, immediately it becomes hot. It warms up as energy is released to it. Heat energy is a very difficult energy to can store, more especially when used in an open environment or open system. It is very difficult energy to store, as it can transfer in 3 different ways: from warm surroundings to cooler surroundings. Warm heat energy, keep that in mind. It is very difficult to can store it. As I said, more especially in an open system. It can be transferred in 3 different ways, from warm surroundings to cooler surroundings. What are those 3 ways? conduction, convection, or radiation. Energy can be useful and also wasted energy. Once it is useful, in other words, it is used for the work that is supposed to be used for. But that total amount of energy, certain part of it can be used properly so, but be rest assured that the other portion will be released to the environment. The other one will be released to the environment. Useful and wasted energy. Energy comes in, let us look at a picture. Energy comes in to be used for a certain purpose as an input energy. Useful output energy, it is used here where it's supposed to be used. But look, there is a certain portion of it, as I said, that will go out as wasted output energy. It will come in as an input energy. It will be used where it's supposed to be used. But a smaller portion will be released to the environment as a wasted output energy that will be released to the environment. That will be released to the environment. Useful and wasted energy. Key concepts. Very much important concepts. Wasted energy must be reduced in order to save our energy sources, such as coal and fuel. Very much important. We cannot afford to lose too much energy. We cannot afford for that energy to be released to the environment. It is very much important for us to save that energy. By saving that energy, in other words, in return, we are saving our sources of energy, such as what? Such as coal and fuel. The issue of insulation. We must make it a point sure that we save energy. I like this sticker that will always says, if you don't use your geyser, switch it off. If you don't use a geyser at home, switch it off. where possible, during the day, switch off the lights. One way or the other, you are saving energy by so doing. The more input energy converted to useful energy, the more energy that comes in. The more we use it the right way, the more we save energy. In other words, this is one way we can save energy. When we put it energy, we use that energy correctly, so we can be able to save that energy. The more input energy converted to useful energy, the greater the energy efficiency. I said key or most important concepts. In a solar collector, that picture of solar panels on top of the house. In a solar collector, a black dull surface that absorbs sunlight. I said it. They absorb energy from the sun, direct energy from the sun. Solar heat is absorbed by what? By copper pipes. Insulating materials trap heat and never loses heat easily. Insulating materials, the solar panels, they trap heat from the sun. That heat can be very useful to us. Remember I said, once the heat is there, that energy is there, we use it rightfully so, we can be able to save it for the future. More especially, the resources such as fuels and coal, where in most cases we get energy from. It cannot be released to the environment. The sun can be used to heat water and produce electricity. That's true. Water produces electricity. Energy from the sun can be trapped on the solar panels and converted into electricity, and we can use that electricity. It is important to save water or to use water wisely so, because from the very same water, energy can be produced and we can use that electricity, and also we can save that electricity. Energy produced by the sun is called solar energy. Energy produced by the sun is called solar power. Heat always moves from an area of higher heat to an area of lower heat And through that process, as it moves, the other one is released to the environment. An insulator is a material that does not allow easily heat energy to be transferred. That is why I'm saying that it's very much important to have insulating materials to prevent much heat to be released to the environment, because we need that energy. Useful energy. Useful energy is energy in the place we want it and in the form that we need it, and we use it in the correct way. That energy is useful once that energy is at the right time, right place, and in a correct form. We use it, we get everything important for us from it. Then we know that we have used that energy rightfully so, or the right way. But vice versa, that energy, it becomes wasted energy. And once it is a wasted energy, it is released to the environment. That's what I'm saying. Useful energy, we use it the correct way. Stored at the right place, in a correct form. Then we'll get what we want. But once it cannot be used as it's supposed to be, we are going to have what we call wasted energy. It's the energy that is not useful. And once it is like that, it's going to be a wasted energy, is going to be released to the environment. Useful energy and wasted energy both end up being transferred to the surroundings, which become warmer. Released to the environment. Where it's going to be accumulated is going to be warm. More especially when the sun sets, you move around the environment, you will see that there are places that are cool, but there are other places that are hot. In other words, those places that are hot are the places in the environment that energy has been released to. Right. Tools that you are using every day, appliances, it can be electrical appliances, the vehicles, no matter how big they are, machines, all provide useful energy outputs. A car can use energy from petrol or a diesel. But the most important thing is that it must be converted to be a useful output energy that can be used in different ways. Either it's from the tools, the appliances, it can be in vehicles or machines, all provide useful energy outputs. During that process, some of the energy is wasted or lost. During those activities, some of the energy is going to be wasted, or we are going to lose it. The useful output energy, is therefore less than the input energy, as some of the output energy is wasted. In other words, when the input energy is more and we use it through the process, at the end, we won't get the same output energy as the same as input energy. Why? Because the other energy will be released to the environment as wasted energy. Will be released to the environment. If we put 100% here, we won't get the same percentage at mid-end, because the other one will be released to the environment. An example, it's a light bulb. Look at the light bulb. Where the input energy is electricity, it's an input. And the useful output energy that we need is what? It's light. We need light. But somewhere, somehow, there is energy lost there in the form of heat. Do it practically in the presence of a teacher. I'm saying an example is a light bulb where the input is electricity. The useful output is light. But when you touch it, you'll feel that it's hot. In other words, there is energy that is lost there in the form of heat, or wasted energy in the form of heat. Useful energy. Let's take the following examples. In a car, is very much important for what? Movement of that car. But also is going to be wasted in the form of a heat and a sound that will come from that car. Either petrol, diesel. That energy is converted. That car will be able to move. It's very useful in that way when that car is moving. But at the same time, there is going to be energy wasted there in the form of a heat and in the form of a sound from that car. Input energy from electricity to the TV. To the TV. We see light from TV, useful. Sound from TV, useful. But also, there is going to be wasted energy in the form of a heat from that TV. Useful because there is light from that TV. Use correct way. Sound, we can hear from that TV, but there is going to be wasted energy in the form of what? In the form of a heat. The food that we are eating every day. As I said, energy is the ability to do work. We can be able to move. And our body gets heat. But some heat is going to be wasted from our body, released to the environment. It won't be stored as it is. We can lose it through sweat. It's going to be released to the environment. You will see it clearly during winter time when you play soccer, either soccer, or when you exercise, or during the athletics time. You will see that energy when it is released from our bodies to the environment as a wasted energy. Washing machines at home. It is useful for the movement and heat waste sound in form of what? Of a sound. And some heat and shaking. Then we start to lose it. We need it for the movement, for us to be able to wash. But somewhere, somehow, there's going to be a sound, we start to lose it. The machine starts to shake, we start to lose it. That energy. So it's very much important to know that one way or the other, we must be able to save energy. We measure energy in joules. For an example, a 100-watt light bulb needs 100 joules of electrical energy per second to function properly. For the next coming grades, we measure energy in joules. For an example, a 100-watt light bulb needs 100 joules of electrical energy per second to function properly. Yet, it only produces approximately 5 joules of light energy per second. That means that 95 joules of heat energy per second are wasted. Huge amount of energy. If that bulb, it only needs 5 joules, In other words, we are losing too much of energy through light bulbs. Plus or minus 95 joules per second as a wasted energy. That is why we end up having the bulbs that can save energy. You got energy saving bulbs because too much energy is lost through the bulbs. The useful output energy is a system is always less than the input energy because we seldom get an energy system that is 100% effective. Yes. There is no way we can get a system that we are saying that we know this system is going to use this energy or is so effective that it reaches 100%. No ways. Somewhere, somehow, that system is going to lose energy. Some of the input energy is transferred to the surroundings and is not useful. Some of that energy that is not used is released to the environment. Very much important word, key word, as wasted, and we don't need energy to be wasted because it's very much expensive. But it will be released to the environment. The more input energy converted to useful energy, the more input energy converted to useful energy, the greater the energy efficiency of the system. If that system can be able to use the higher amount of energy, then we know that that system is good because it saves energy. And if an energy efficiency system produces less wasted energy, that's true. That's true. The more is using energy effectively so, the more it saves energy. And it's very much important to have such a system in place in order to save energy. The more we save energy, the more we save the resources. We need insulating materials to save energy. Thermal insulation is the reduction of heat transfer between objects in thermal contact in range of radioactive influence. In other words, we must be able to use materials that can save more energy from being released to the environment. Thermal insulation can be achieved with special engineered methods or process, as well with suitable objects, shapes, and materials, as I said. High engineering methods as well as materials can assist us to save energy. Look at that solar panel. Insulation, energy saving, and energy transfer to the surroundings. We learned about conduction, convection, and radiation. There must be means for us to be able to save energy. Because once it's not saved, it's going to be released to the environment as a wasted energy. These are the types of insulators that can be used to save energy. Such material contains air spaces. Remember, air is a bad conductor of electricity. That is why it can be used as an insulator. Materials containing air spaces are the best insulators ever been seen. Materials that contain air spaces are the best insulators. Example, thatched roof. Air is trapped in the space between the grass of the thatch. We know thatched roofs. They are commonly used now. Why? Because the space in between that contains air are very useful insulators. Wool. Some clothes are made out of wool that we are wearing. Good insulators. Cork. Good insulators. Feathers. Good insulators. Grass. Good insulators. Styrofoam. Good insulators. Very good insulators. These are the types of insulators that helps us to do what? To prevent heat loss to the environment. Look at the pictures. Insulation, energy saving, and energy transfer to the surroundings. Look at the pictures. The first one, shines here silver. Why? Good insulator. Look at the house. Painting outside, everything. The roof. Good insulators. Look at this. Either made out of wool. Good insulators. Wood is also a good insulator. Insulators are used to reduce heat transfer. Materials that keeps us warm. Woolen clothes prevent the body heat from escaping, e.g. jerseys, woolen hats, gloves, jackets. We know that they keep our body warm, preventing heat transfer. Bedding, e.g. blankets, comforters, duvets, and etc. It keeps people warm when it is cold. I said that, good people. The air is trapped between the fibers, and therefore extra insulation is given. Remember, I said air, bad conductor. The air is trapped between the fibers, therefore extra insulation is given. Thermal jacket, worn more especially by people who are living in places that got ice, such as Russia, Eskimos. people keep them warm in temperature that are below 0 degree because they are wearing clothes that are made out of good insulators. At the end, it is very much important